Good day, Year 9. Today's lesson will be focusing on Index Law 1. Our learning intention today is to how to use Index Law 1 to solve problems. Success criteria 1. Our ability to be able to expand and simplify to solve problems. And 2, to apply Index Law 1 to simplify algebraic expressions. We already know some basic algebra and measurement facts because that was the unit of work we did before the end of term 1. From year 8, you also know some basic integer facts and also you know how to solve equations. So all these things will come handy today with our lesson. Let's focus on some key terms, some literacy, mathematical literacy. When we talk about index form, we're talking about this whole 3 to the power of 4, for example, is in the indexed form. This is the index form. Four is referred to as the power or index. We can also call it the exponent. 3 is what we refer to as the base of our index form. Now, 3 to the power of 4 means 3 times 3 times 3 times 3. So that is the expanded form, or that is the expanded form. So 3 to the power 4 is the index form. This means mathematically 3 times 3 times 3 times 3. This is the expanded form. And if you used your calculator or if your times table is good, 3 times 3 is 9, 3 times 3 is 9, so that gives you 81. 81 is the value. If we ask you to evaluate, then your answer will be that. If we say simplify, then you leave your answer as 3 to the power of 4. So if you did this calculation, which is in the expanded form here, if the question was to evaluate, you will leave your answer as 81. But if the question was to leave your answer in index form or simplify that calculation, then your answer will be 3 to the power of 4. Let's have a look at that. We have 11 to the power of 3 times 11 to the power of 4. 11 to the power of 3 simply means 11 multiplying itself 3 times. Remember, it's not 11 times 3. It is 11 repeatedly multiplying itself 3 times. And 11 to the power of 4 also will be 11 multiplying itself 4 times. So 1, 2, 3, 4, 5, 6, 7. 11 multiplying itself 7 times. So 11 to the power of 7. And let me also say, the index form, this index form, is simply a shorthand or a condensed form of writing all that calculation. It's more or less, if you like a shorthand. It's a shorthand. Having trouble with that. It's a shorthand. Or condensed form of writing all that long calculation. Now, 3 to the power of 2 times 3 to the power of 4 means here 3 multiplying itself twice, and there 3 multiplying itself 4 times. So this is the expanded form, and the condensed form or index form is simply 1, 2, 3, 4, 5, 6. So 3 to the power of 6, as you can see. But let's try this one. As you would have noticed, the base was 11, the base was 11. The base here is 3, the base here is 3. Now, let's look at this. The base is 4, and this one, the base is 3. But what is the meaning of 4 to the power of 5? It's 4 multiplying itself 5 times. 1, 2, 3, 4, 5. That's 4 to the power of 5. What about that? 3 squared. That's 3 multiplying itself twice. How does this simplify into? Well, this simplifies into 4 to the power of 5 times 3 to the power of 2. There isn't anything else we can do. It gets back to exactly the original question we had. The reason the bases are different. This is base 4 and that's base 3. So we can't say we have 1, 2, 3, 4, 5, 6, 7. We can't say 4 to the power of 7, or we can't say 3 to the power of 7. That doesn't make sense, does it? Because these are 4s and these are 3s. Doesn't make sense. So it will be left as 4 to the power of 5, because that's what we have. 1, 2, 3, 4, 5. 4 multiplying itself 5 times. So the shorthand is 4 to the power of 5. And we are multiplying that by 3 to the power of 2. You got that? Okay, so the base is very important when we are looking at this. Let's do a bit more practice before we state the law. So we have 2 to the power of 3 multiplying 2 to the power of 5. So 1, 2, 3. 1, 2, 3, that's 2 to the power of 3. That's 2 times 2 times 2. And then 2 to the power of 5, 2 times 2 times 2 times 2 times 2. 5 of it and 3 of it. So in all, we have 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power of 8. We can condense that because the base is still 2 and it's still repeating 8 times. So 2 to the power of 8. What about that? 6 to the power of 3 and 6 to the power of 4. So as we can see, 1, 2, 3 multiplying itself 3 times, that's the expanded form. And that's 1, 2, 3, 4. That's the expanded form as well. And then we simplify. So 6 to the power of 7, which is precisely what our success criteria 1 tells us. Expand and simplify. But as you will notice, from all the examples we've done where we have been expanding and simplifying, if you pay close attention to the indices, 6 to the power 3, 6 to the power 4, all that we are doing is we are doing 6 to the power 3 plus 4. We're just adding the powers to give us 7. So 6 to the power of 7 as our answer. So the first law says if you have a to the power of m multiplying a to the power of n, then it is the same as a to the power m plus n. That is your first law of indices. So when multiplying terms with the same base, add the powers. If they have the same base, you simply add the powers. That's our first law. So now we can apply our second success criteria, which is using the index law 1 to simplify algebraic expressions. So we've been given 7 to the power of 3 times 7 to the power of 8. Remember, the base is 7. The base is 7. So if the base is 7, then all that we need to do is to add the powers, which is 3 and 8. So 3 plus 8, that gives you 7 to the power of 11. 7 to the power of 11. That is how you apply success criteria 2. Remember, when the bases are the same and they are multiplying, you simply add the powers. We have c to the power of 3 times c to the power of 6. Again, here our base is c. That's the base. The base is c. So since the base is c, we just simply have to add the powers because they are being multiplied. So c to the power 3 plus 6, which is c to the power of 9. Remember, it's important to check what the base is. Then you simply add the powers if the bases are the same. Let's be very careful with this question. We have 4h to the power of 5 multiplying 3h to the power of 9. The coefficient 4 and the coefficient 3, remember, are not being raised to any power. So 4 to the power 4 times h to the power of 5 can be written as, so we can write this section here as 4 times h to the power of 5 times 3 times h to the power of 9. Now we can rearrange all the numbers to one side, which is 4 times 3, and then we can put the h's on the other side, which is h to the power 5 times h to the power of 9. Of course, 4 times 3 gives us 12, but h to the power 5 times h to the power 5, the base is h. Because the base is h and they are multiplying, we have to add these powers. So 5 plus 9, and that gives us 14. So 12h to the power 14. Remember, the power 5 is only for h, not for the 4. The power 9 is for the h. It has nothing to do with the 3. If the power 9 applies to the 3, we'll write it as 3h to the power 9 in bracket here. Then it means this will be 3 to the power of 9 multiplying h to the power of 9. Okay? But this is different. But this is not what we were given. So We'll look at questions like this in future time. All right. So for the time being, let's focus on these ones. Simplify and leave your answer in index form. So here we don't need a calculator to do this calculation. So don't be worried, how am I going to find 5 to the power of 11 and 5 to the power of 7 multiplying together? That's a huge number. If you understand, it says index form. So all that we need to do is you ask yourself first, what is the base? The base is 5. And the base there is also 5. Because the bases are the same and they are multiplying, we can simply write the base and add the powers. Add the powers. And so that is 5 to the power of 18. And it's easy done. Easy done. Remember, your base doesn't change. Your base is 5. And you simply add the powers. You can use expand and simplify to do this, but that's longer and less efficient because we know the law, so we just have to apply the law. Now, be very careful here. Again, here you can see the base is C. You have 5 times C to the power of 3 times C to the power of 2. The power 3 here is only for C, not for the 5. So the 5 is on its own. So since the base is C, we have times C, and the power will be 3 plus 2. And so that gives us 5 times C to the power of 5. Now, you recognize in algebra, this multiply here is redundant. We don't need it, so we drop it, and so our final answer will simply be 5C to the power of 5. That will be our final answer. We all know, all mathematicians know that between the 5 and the C to the power of 5, there's a multiplying sign there, but it's not necessary to write it. So that's your final answer. That's a 5. Right. Again, let's be very careful. Let's rewrite this a bit out by introducing the multiplication signs, which we know is there, but normally not written. So you go 5 times b to the power of 4 times c to the power of 5 times 6 times b to the power of 3 times c to the power of 2. Now we can regroup things. The numbers together, the similar alphabets together. That's a B and that's a 6. Let me just write it well. So let's group the 5 times 6, the numbers, now times the letter B to the power 4, and we have the letter B to the power of 3, and then we have times C to the power of 5 times C to the power of 2. Remember, it's okay, you can always interchange positions as much as you keep the mathematics consistent. 5 times 6 will give us 30. That's the easy part. Now we have times. Because the base is B and B, that will be B to the power 4 plus 3 times c and c, so c to the power 5 plus 2. I'm applying the first law of indices, law 1. So this will be equal to 30 times b to the power of 7 times c to the power of 7 as well, because 4 plus 3 is 7 and 5 plus 2 is also 7. So we'll tidy it up and do our final answer will be 30 b power 7 c power 7, and that is our final answer. Any questions? Let's have a discussion. Google Classroom. Let's have a discussion there. We need to be very careful with this question because of the negative sign. Right. Let's rewrite this out. So 3 multiplied by a to the power of 5 multiplied by b power of 8 times negative 8 times a times b squared. And you'll recognize that when it says a, it means the power is 1, but it's normally not written. The power is not 0, it's 1. Okay. That's the convention. Now we can group the numbers together. 3 times minus 8 times a to the power 5 times a times b to the power of 8 times b squared. Now, positive times negative. Of course, it will give us a negative result. And 3 times 8 is 24. Now, times a power 5 plus 1. Remember the a here, this is power 1. It's normally not written. It's not 0. We'll explain that in subsequent lessons, because anything to the power 0 is 1. But we'll explain that in subsequent lessons. B to the power 8 plus 2. So this will be minus 24 times a to the power of 6, because 5 plus 1 is 6, times b to the power of 10. And then finally, you tidy this up. Minus 24 a to the power of 6, b to the power of 10. We drop the multiply signs. And that will be our final answer. Again, as I said, if you have questions, message me at Google Classroom and we would discuss it further from there. We're still applying success criteria 2, which is applying the index law 1 to algebraic expressions. Simplify. Okay, we will look at our knowledge of how to solve equations, but we're still applying index law 1 to simplify algebraic expressions. Now, as you look at that, you see, if you have a plus a, it becomes 2a, isn't it? So, using the same ideas, you have 7 to the power of x plus 7 to the power of x. So, our next step here is simply 4 times 2 times 7 to the power of x equal to 56. Because 7 to the power of 6, 7 to the power of 6 is 2 times 7 to the power of 6. Just like a plus a will become 2a. Now, 4 times 2 will give us 8. 80 times 7 to the power of x equals 56. At this point, because we're interested in solving for x, we want to free the term that involves the x. So it's multiplying, so the inverse is to divide. So I'll divide here by 8, and whatever I do on that side, I do on the right-hand side as well. I divide by 8. So I'll be left with 7 to the power of x, and this must be equal to 7, because 7 times 8 is 56. Now again, as you know, this 7 is 7 to the power of 1. We normally don't write that 1, but that's what it is. Now, if this power of this is 1 and this power is x, and they are all base 7, therefore it means x is equal to 1. And so, problem solved. X is equal to 1. Because the bases are the same, so the powers must be the same. Because of the equal sign here. Says this part is equal to that part. So if this part is equal to that part, then x must be equal to 1. Any questions? Can address by your postings at Google Classroom. It's an interesting question. A single bacterium in ham, and that's the sandwich there, which is being pursued by that canine, the dog. Now, a single bacterium in ham sandwich divides into 2 after half an hour out of the fridge. The number of bacteria doubles every half hour after that. The number of bacteria after 5 hours is, well, since this bacteria doubles after every single time period, and here our single time period is half an hour. So you can look at it this way. If you had bacteria and time period, probably let me just start with, I prefer to start with the time period first. Let's say time period bacteria. Just a little demonstration. So at time 0, we had a single bacteria. At first time period, it doubles. Remember, this is half an hour. Second time period, which is 1 whole hour. It doubles again, so the 2 becomes 4. After 1.5 hours, that's your third time period, this 4 doubles again, so it becomes 8. After your 4th time period, which is now 2 hours after the sandwich has been outside, this 8 doubles again, it becomes 16, and so on. So we can continue with this. If you're a visual learner, you can continue with the time periods until you get to 5 hours, and then you'll be able to answer the question. But you know, if this was an exam, that will be an inefficient method, because knowing that we've understood today's lesson is for us to be able to predict, because now that's to be a higher order thinking skill, to be able to jump from this visual representation and predict using a powerful formula. So let's examine the time periods and the numbers we have here for bacteria carefully. If you look carefully, you'll be able to say that the number of bacteria will be given by, because it's doubling, 2 raised to the power of x. How do I say that? If the x here is our time period, so let me just say 2 to the power of t, where t is the time period. Why do I say that? You see, when this time t is 0, when the time t is 0, you have 2 to the power of 0, which is 1. I will explain that in the next 2 lessons after this, or probably the next lesson after this. If t is 1, 2 to the power 1 is 2. If t is 2, 2 to the power 2 is 4. If t is 3, 2 to the power of 3 is 8. You see, 2 to the power of 3 is 2 times 2 times 2. That's 8. If t is 4, you have 2 to the power of 4, which is 2 times 2 times 2 times 2, and that is equal to 16. And that's what we have there. So we continue. So it means this is the relationship that shows you the bacterial growth. If you're not seeing it, you can do 5 and you see that it becomes 32, and 6 and it becomes 64, and so on, because this doubles. And you can see that 2 to the power of 6 is 64. So after 5 hours, there are 10 time periods in 5 hours, because it doubles every half an hour. So 1 hour is 2 time periods. 2 hours is 4 time periods. So 5 hours is 5 times 2. That's 10 time periods. So all that I need to do is to work out what is the number of bacteria will be equal to 2 to the power of 10. So grab your calculator, and 2 to the power of 10 is simply 1024. And so that will be the correct response. Remember, prediction is a higher thinking order skill. So to be able to see what's happening, come up with a relationship, which is an index relationship, to help you solve the problem, shows that we are understanding that lesson. Otherwise, you can continue time period 7, time period 8, time period 9, and time period 10. Remember, you double that, that becomes 128. So let's grab the calculator now. You had 64 times 2, that gave you 128 for time period 7. So for time period 8 times 2, that gives you 256. For time period 9, that 256 multiplied by 2, that gives you 512. And 512 times 2 again, that gives you 1024. So you can see we can continue with that table, because That was time 0. That's half an hour. That's 1 hour. 1.5 hours. That's 2 hours. 2.5 hours. That's 3 hours. 3.5 hours. That's 4 hours. 4.5 hours. That's 5 hours. So you see, 5 hours is the time period equivalent to 10. That is inefficient. Yes, it shows understanding, but once you've seen the pattern, at some point, you need to be able to generalize. This is a generalization. It's a generalization that simplifies and shortens the time you need to reach your answer. So many times, the argument has been, oh, I knew what to do. I could have answered all the questions, but I didn't have sufficient time. Well, your teacher is expecting that to answer this question, you will not go through that rudimentary track. You will see the pattern and stop at 4, write your generalization, and use it to solve the problem. That's what I am teaching you to be able to do. Yes, continuing with the pattern shows understanding. Yes, I appreciate that. But at some point, we need to grow up. We need to be able to generalize and predict. Because if I ask you after 25 hours, how many bacteria would have grown? Of course, you couldn't continue with this generalization method. I mean, we couldn't do this without a generalization method, because then you need a very, very long time to go from time period 11, 12, 13, 14, 15, and so on. That's inefficient. So at some point, understanding these things, making generalization, testing our generalizations that they are true, is the crux of what we are learning. All right, thank you. So let's summarize. Today we looked at Index Law 1. Our learning intention was to use Index Law 1 to solve problems, which we surely did. Success criteria, we started off with expand and simplify, and we moved on to apply the law in solving algebraic expressions. We focused on Index Law 1 in this lesson. Please make sure you do the companion workbook questions located on your Google Classroom, and also make sure we're doing additional homework on mymathsonline.com.au. And please, if you have some time, subscribe to my YouTube channel, Chris Tabby Maths. If you type that one in as your search criteria, you'll find it. Thank you very much for your time. Looking forward to lesson 2, which will be looking at Index Law 2. Thank you.